Okay, almost done here. We're still talking about rhombuses. So I have my JKLM as a rhombus. This time I want to prove that line segment MK, so this diagonal, bisects angle JML and angle JKL. So I'm going to prove this statement. So I'll put the other one in parentheses. I could solve it another way and prove that line segment JL bisects MJK or MLK, just by doing a couple of things differently. But if I prove that one of these bisects the angle, then that tells me that the other bisects the angle as well. So once again, my first statement is always the given statement. So I'll start off with JKLM is a rhombus, and that has been given to me. Okay. Next statement is that JM, line segment JM, is congruent to line segment LM, and that line segment JK is congruent to line segment KL, and this is the definition of a rhombus. Remember, a rhombus is a parallelogram where all the sides are the same. So basically, they're all just going to be congruent to each other, but I'm going to split it up separately to kind of help us see what's going on here with my further steps. So I'll say that line segment JM is congruent to line segment, which one did I say? LM. And I'm going to group it with a line segment JK is congruent to line segment LK. So I have JM and LM, so these two, and JK and LK. And this is the definition of a rhombus. Okay, so I have these two are parallel. And even though they're all the same, I'm going to go ahead and signify how I wrote them out. Okay, so I have JM and LM there with the 1, and I have JK with LK with the 2. Okay, so I have two sides, and then I can also say that line segment MK is congruent to line segment MK. And once again, that's pretty obvious. A line is equal to itself, and that is reflexive. So I'll do 3 right there. Okay, so I have side, side, and side. So that's going to prove to me that triangle MJK is congruent to triangle MLK by side, side, side. So I have this top triangle here. Okay, it's congruent to this bottom triangle down there. And the way I've proven it, I can kind of just like fold this over that MK line and say, like, this one flips down here, that one flips over there. Okay, and so these two triangles are congruent. And so now I can say that angle JMK, so angle JMK is congruent, and that one's this one right here, is congruent to angle LMK, which would be LMK right here. And I can also say that angle JKM is congruent to angle LKM. So that would be JKM is over here. Do my double and my LKM. So remember, I said that this triangle, you could basically flip it over that MK line. And so these two sides are congruent, which would also show me that these two angles would be congruent because they're going to be the exact same triangle if I fold it on top of each other. And if we remember how I prove that, that would just be the CP, CTC, or the congruent parts of congruent triangles are congruent. Since I can take that triangle, put it on top of the other one, and they're the exact same, that tells me that those angles are going to be the same. Okay, and if you think about, we kind of talked about this earlier with bisecting lines. Okay, if you bisect a line, that means you cut it in half, which tells me that the left side is going to be equal to the right. If I half something, I want to split it into two equal parts. So if I bisect an angle, that means I'm going to split it into two equal parts. And by looking at this and looking at my last statement, this angle is equal or congruent to that angle. So that tells me that MK bisects those angles. So I can go ahead and write down my proof statement of line segment MK bisects, and it's going to be angles JML and angles JKL. And that is going to be the definition of an angle bisector. Okay, so once again, since these two angles are the same and they're being split by that line MK, that tells me that that's cutting this whole angle in half since it's split into two equal parts. And so that tells me that it is bisecting that angle. So here my statement would really be that if a parallelogram is a rhombus, then the diagonals will bisect the opposite angles. So I'll say, to keep it in the same terminology, I'll say that diagonals of rhombuses bisect opposite angles. So once again, we can now use this as a proof for following statements as well.